the first instar larvae, as I say, feed openly on the leaf surface. They do not fold leaves. And there's close up of the silk strands that they produce. So that's their attempt at protection. But clearly, in terms of insecticide sprays and such like, it's nowhere near as protective as being inside a leaf fold. So you can probably see where I'm going with this in, the vulnerability to pesticides. The first instar is that stage that we should be targeting for insecticide control. So the larvae, the caterpillars, larvae of this moth develop through a number of stages, 5 stages, or instars as they're called. And so the first instars we just saw is exposed on the leaf, not folding leaves, but the 2nd to 5th instars, as they get bigger, all fold leaves. These pictures here that I'm showing, they've been manipulated, exposing the larva. Normally it would be inside a fold. They're glossy, translucent yellow-green on the sides and darker above. There's usually some sort of dark line, as you can see here. Pretty nondescript, really, but they do have a light brown head and spots near the head, which is pretty diagnostic, the spots just behind the head. And the mature 5th instar, which is the last larval stage, is almost 1 inch in length. And actually, they do reach 1 inch, and that might be another difference between our species and the California. Most of the literature suggests that their larvae do not quite reach 1 inch in length, whereas ours seem to do that. So maybe slightly bigger. Development from the 1st to 5th instar in the summer, it takes approximately 3 weeks. Can be as little as 2 weeks when it's really warm. Like all insects, they develop according to temperature. They're temperature driven in terms of development. And as I've said, the larvae spend their lives within folded leaves, at least the 2nd to 5th instars. Interestingly, they only use 2 or 3 leaves during development, I guess depending on how big a leaf that they choose to fold. And if the leaf is opened, the larvae wriggle and fall to ground. So that's another diagnostic feature, that these caterpillars are very wriggly and will drop to the ground if disturbed. So the actual rolls and the folding, this species and these species are called leaf folders, but actually what they're doing is rolling the leaf in most instances. They do actually fold as well, I must admit, but most of the time it's rolls, a bit like on this leaf here, where there's 2 larvae, one at the top and one at the bottom there, and you can see the silk strands that they use. As the first instars, they use the silk for protection, and then later on they use the silk to actually form the rolls of the leaf, or the folding of the leaf. Here's some more examples of leaf folding or rolling. The 2 on the left are more rolls, whereas the one on the right is more of a fold. So they'll do both. And once it's been done, the rolls being created, the larvae feed inside on the free edge of the leaf inside the roll, gradually feeding on the entire surface that's been rolled. So the rolls will end up, brown and discolored because they're totally been eaten, or at least the chlorophyll being removed from the leaf. And they remain inside the rolls at all times, unless making a new one. And as I've mentioned, they only do this once or twice during their lifetime. And when they do that, they do it at night. They've never been seen to make a new fold during the daytime. And there's some more examples here. But they all have the same end result, in that there's reduced photosynthetic surface of the leaf, and that may be a problem. And we're actually doing research to see if that is actually a problem or not. So 5th instar, almost 1 inch in length, ready for pupation. The larva begins to turn a reddish color, like this one here. And then the larva forms an envelope as a pupation site by cutting a small piece of leaf on 3 sides and folding it over. So definitely folding here and not rolling. And it's like literally a little envelope sealed on all edges, all 3 edges, and much more, well, protected in just a different way from a roll, and maybe more secure because they use a lot more silk to tape down the edges, if you like. So if you open up the envelope, you'll find the chrysalis or pupa, to give it scientific term, like this. So this is a newly formed one. It's still fairly pale, and once it's matured, this is what it looks like. It's about half an inch long. Should be half an inch, not half an inch. Half an inch long, turning darker with maturity, and it's in this stage for about a week to maybe 12 days under cooler conditions. So it's a fairly short period of time in the summer, but it is also the overwintering stage. So this is what they are like at this very minute in the vineyards in Washington, a pupa on the ground of the vineyard, not exposed like this, but within the little envelope they created, the larva created. So this is a whole bunch of pupae that I've opened up for experimentation. So looking at some pictures now of what the leaf folds in the vineyard look like. Depends, of course, how large the infestation is. This is a pretty heavy infestation. You can see some fresh rolls there, and you can see the older rolls where damage has been done to the leaf and it's browned. And so it can reduce leaf area quite considerably, as you can see from here looking against the sky, reducing the leaf area and likely reducing photosynthetic efficiency. Nobody's actually proved that, but it is probably very likely. Again, this shows an even more dense concentration of folding leaves. You'd think when you look at something like this, each fold has a caterpillar in it, but in our early research we found that that is not the case. In some instances, only 20–30% of the folds you find in a vineyard, particularly late in the season, have a caterpillar in them. Once the leaf is folded and the caterpillar's moved on, then that leaf remains folded. So increasingly during the season, the damage looks worse than it actually is in terms of caterpillars out there actually feeding and causing more damage. But severe outbreaks can ultimately, they stay on the leaves. As I said, they're in the leaves, but in severe outbreaks like this, where it's almost browned over, you can get larvae on the grapes, and then they can be included when harvested. And so we've had at least one report of this happening. And this is a photo here of that report, where grapes are present within the harvested fruit. Sorry, the caterpillars are present in the harvested fruit. So it's a rare occurrence, but it is possible in extremely high population densities, presumably. Another possible impact is on fruit ripening, and maybe reducing the leaf area can create opportunities for sunburn, sun scald. So that's something else we have to think about. And in young vineyards, and this is how the pest became apparent to us early on, 5 years or more ago, when populations of larvae would defoliate young vines, like in the slide here. These are not defoliated, but vines with this sort of limited leaf material can actually get defoliated by large populations of leaffolder. So that young vineyards may be at more risk from major damage. Interestingly, the damage often appears to be restricted spatially, as in this slide here. So you can see, in this row here, there's quite a lot of unaffected grapevine, and then further down, there's a whole bunch of affected vine. And similarly over here, and if we could go down that row, we'd see that it didn't continue all the way along. So it's curious. We don't quite understand why, although we've learned this year that the moths tend to like, the next generation of moths tends to like to lay their eggs where the previous generation of caterpillars have been. So maybe this is a result of compounding of population, which just doesn't make sense for the caterpillar really. Or, you know, if the moth is trying to find a resource for the caterpillars, then it'd be better off finding fresh new growth. But for some reason, they seem to be attracted to laying eggs where previous caterpillars have been. So this intense damage may be a result of extra high populations of caterpillars caused by the females laying in particular areas. We need to do more research on that to see if that is the case. There are a couple of alternate hosts outside the vineyard. These three are the ones that are mentioned in the literature, primarily for the California grape leaffolder, but they also appear to serve as alternate hosts for the white-headed grape leaffolder, and there may be others too. I started looking at some alternative foods last summer, and there may be others. So it may not be restricted to grapes. So our research began seriously in 2018, and interestingly, this species has not become a widespread concern throughout the Eastern Washington grape industry. Most appellations are free so far of grape leaffolder. It's only in these areas shown here, Red Mountain in particular, Mattawa as well, and the Tri-Cities and Horn Rapids, that the significant populations occur. 2019, we added Prosser to that list, but beyond that, although we haven't really surveyed for a couple of years now, it doesn't, you know, we haven't had reports of it from other locations, which is a bit surprising because the moth is fairly, you know, mobile. It's got wings, it can fly readily, it can fly quite fast. It's curious that it hasn't really expanded its range within Eastern Washington to date, anyway. So in 2018, our first year research, we monitored for adult white-headed grape leaffolders, macularis, using the pheromone, which is available commercially for the California grape leaffolder. The research down there developed a synthetic pheromone for this species. And I think at the time we weren't sure what species we had, so we thought we'd try it. And we got some success, but limited. Only 5 traps out of 27 caught moths, but they caught a lot of moths, those 5. But again, only in the first generation, the generation emerging from pupae that overwintered. So you can see in the graph there, we had quite good numbers early on. We thought, great, we can monitor. But then in the subsequent generations, and as you'll see later on, there are other generations during the summer, we didn't get any response to the pheromones. So it's definitely suboptimal for monitoring our species. But during that early period, we did get up to 254 moths per trap, but then no moths in the traps from mid-June to late August. And then in 2019, no moths were trapped at any time of the season. So we abandoned the use of that synthetic pheromone at that point. That was, you know, when it was working. But it was curious that just a few traps had this result, and the majority not, and only in the first generation, which makes sense, I guess, if it's not the right pheromone, which it won't be, because our species is different from the California species. Closely related, but not exactly the same. So we shifted to testing in 2019 fermenting molasses bait traps. Now these are traps that have been used by moth collectors, lepidopterists, for decades to collect moths. Moths at night are very attracted to this fermenting material, and it's effective, cheap and reliable, and it works well with the grape leaffolders, as you can see here. The only problem is you get some other moths attracted too. But in a vineyard situation, there's not too many other moths around for most of the season anyway. And so for the last 2 seasons, traps like on the left here, bucket traps, simple bucket traps, filled with, not filled, but with a mixture of of this fermenting molasses lure has provided a good way of monitoring adult populations. And it seems to be reliable too, particularly for the second and third generations where, you know, the pheromone trap wasn't working at all. So in 2018, in our initial work, we found an average from a number of sites we were looking at, more than the 3 that are on this graph here, but we found an average about 1 folded leaf per vine in June to July. So that wasn't a great number, but then that increased to 10 folded leaves per vine in August, September. We've seen situations much greater than that subsequently. But interestingly, as I said earlier, only 25% of these in August, September anyway, contain larvae. And this graph shows leaf occupancy for the first generation here, and then a second generation late in the season, where leaf occupancy did increase at times because the population increased. This season was intriguing because there was only 2 generations. Subsequent season, we had 3 generations of leaf folder larvae. We speculated at the time that the development of larvae, well, we didn't speculate. We saw that development of larvae was slow during June and July. 2018, it was pretty hot. Well, it is in most years, but exceptionally hot during that time. And it seemed to inhibit development of larvae during that time. And I thought that maybe that was a normal feature of larvae during our summer, whereby we were only going to have 2 generations. The generation that emerged from the pupae in the spring, followed by a very slow developing generation that produced moths and then more larvae around harvest time, which would be good from the point of view of management, because you know, if we could control the first generation fairly well, then the second generation is going to be, you know, you've only got 1 more generation and probably not going to build up enough to cause economic damage. So that was pretty exciting. But of course, with research like this, things change. And the second year was different. We had 3 generations in the second year, but the first was not well seen. And that was the same last year too. The numbers of the first generation have not been very high, suggesting that this species has a problem in overwintering. Appears apparently to be quite a lot of mortality during winter. So this is the mean number of moths per bait trap, and you can see we didn't get anything in the first generation, better showing in the second generation, and a much better showing in the third generation. And that happened again in 2020, where we didn't get very much in the first generation. This is leaf occupancy in 2019, and where you can see there are 3 generations evident. Right at the beginning here is leaf occupancy in June, which is the first generation of caterpillars, and then a second generation of caterpillars in late July, and then a third generation in late August, stretching into September and even October. So in summary, 2018, we only had 2 generations, but in the 2 subsequent years, we've had 3 generations. You know, we're continuing to monitor, but I'd say 3 generations was more typical than 2, but we won't know, of course, until we've monitored for a few more years. So this is a 2020 graph showing the 3 generations again, early on, middle of June. So there's a peak of larvae around mid-June from the moths that emerged during May, then they decline. So this is showing the leaves occupied, this graph. They decline, and then there's another peak towards the end of July, not so great as early on, but of course early on there's less leaves on the vine than there is here, but 50% occupied last year, the end of July. This is from unsprayed vineyards, of course, and then it begins to increase again at the end of August and into September. But you know, it doesn't quite reach 50% at that time. But you can see the 3 generations of larvae during the season, which I think, as I say, is going to turn out to be typical. And bait trapping for last year, again, we didn't get much showing in the first generation, but very good showing in the second and third generation, showing how good the bait traps are for monitoring adult moth populations in the summer and early fall, which we think is going to be important for monitoring when we should apply insecticides, if that's going to be needed. We need to know when moths are out and when they're laying eggs, and I'll talk about that more in a minute. Biological control, there is biological control happening. We haven't studied it very well yet. I hope to do so in the future, but we do know a community of natural enemies exists. Some of them are shown here. The following slides will show some of these in more detail. There's a number of wasp species that parasitize larvae, both so-called endoparasitoids, which means they lay eggs on the caterpillar and then the larvae of the wasp burrow inside and eat them from the inside out. But there's also exoparasitic wasp larvae that actually just feed from the exterior in. So the poor caterpillars have got to contend being eaten from the inside out and from the outside in. And sometimes that does happen. Individual larvae can be parasitized by both types of wasps. These are quite common in many vineyards, and in some seasons they seem to be more common than others. So we've been monitoring during the 3 seasons we've been working on this pest, and we do know there's a community there. And this is one of the external feeding maggots, for want of a better word, that feeds outside of the leaf folder larvae. So the wasps are small, obviously. This is one that's actually responsible for good biocontrol of the California leaf folder species, but we know that it is present in Washington. And because they're so small, they can get into the folds. They also, the leaf folder doesn't completely seal the leaf, and so little creatures like this can get in and parasitize the larvae, and that's what happens. And so you can find, if you unroll leaves, you can find many instances of parasitism of larvae by these wasps. There are also some fly parasitoids. So the previous ones I've talked about are tiny wasps. There's also some tiny flies, not so tiny actually, as this one is, maybe 1/4 of an inch in length. They look like house flies. They're very similar to house flies, but they're characterized by these bristles on their abdomen that house flies don't have to the same extent. And these are well-known parasitoids of caterpillars generally, but we have at least 1 or 2 species that seems to be specific perhaps on leaf folders. So they are helping biocontrol too. And this is a close-up of a leaf folder caterpillar with eggs on it, which are the eggs of the wasps that will hatch, and the maggots will burrow in or feed on the outside of the leaf folder caterpillar. And then we've got less information, but I think they're just as important, predators that are running around the vineyard. And of course in Washington we have good populations of these types of predators because we don't spray a great deal. So these roaming predators also able to enter leaf rolls and folds and kill larvae. Spiders in particular, I think, are very important. And when they do that, they're not going to leave much trace of what was there. They're going to consume the caterpillar. And so this could also explain why we find many leaf rolls or folds without larvae in them. It could be that they've been visited by 1 or 2 of these predators, and the larva of the leaf folder caterpillar has been consumed. Lacewing larvae, minute pirate bugs love tiny caterpillars, and they're thin. They can get into small places very easily, is what I'm trying to say. And also some predatory mites as well will feed on small caterpillars. So I think that's an underrated, I haven't declared how important it is, but I think it is going to be quite important in terms of biocontrol. So the prospects of biocontrol for leaf folders are good, but we just need more research. So moving on quickly, the current goals of research are to determine the economic impact of leaf folders, as I've alluded to. We don't know exactly what their impact is. There's suggestions. We'd like to know more about that, particularly if they have an impact on yield and quality of grapes. We want to determine the population density of leaf folders at different stages of the season and the relationship to fruit production and quality at harvest. Determine the population threshold level for insecticide use. So if we have to use insecticides, what population numbers should we consider that? And also then, and most importantly, what's the best insecticide in terms of efficacy, selectivity to natural enemies, and sustainability of grape IPM. We have a great grape IPM system here in Washington, and the last thing we want to do is to mess that up. So some initial work, we've only been working on these things for a year. And we know there's 3 larval generations. Preliminary assessment indicates no economic damage, but we're awaiting harvest data. Certainly, growers don't consider in most cases that there's been any economic damage, even when populations have been quite high. And last season we had no evidence of fruit contamination. And we had high levels of infestation last year as well, at times, but evidence of suppression in 3rd generation. So it seems that they can build up to high levels in mid to late, midsummer, but then in the 3rd generation, there appears to be suppression going on, probably from the natural enemies I was talking about. So maybe if we can improve that, we can improve things overall. We need to determine the population densities at different stages of the season and the relationship to fruit production and quality at harvest. If we can, have a very low population to begin with, maybe they're never going to build up to high levels or economic levels. And moths emerging from overwintering pupae in May, as I mentioned, appear to be pretty low numbers in most years. And if we can enhance that further or make the overwintering mortality more, then we may, cause enough suppression to prevent any sort of outbreak scenario. We've discovered, as I said, that the bait traps are cheap, effective, and reliable for monitoring the generations of adults for 2 and 3 in the summer. But I'll go back to that. But for generation 1, we may revisit the use of the California pheromone for our species, because it seemed to work, at least in some instances, for the 1st generation. So we need to look at that again, because the bait traps don't seem to work that well for this 1st generation. Determine the population threshold for insecticide use. The 1st instars, as I said, are most susceptible because they're not in the folded leaf. We know now that 1st instars are present 7 to 10 days after adult peak, as determined by the bait traps. So that gives us a guideline for spraying that we worked with last year. And these graphs show 2 separate instances of a grower applying Ulticore, which is a product that's used in grapes and can be used for leaf folders. And it's a residual material, and it provided good control because it was targeted towards the 1st instars in late July, mid to late July, and caused immediate suppression of the population and continued suppression for the rest of the season. We also tried a BT formulation, Leprotect, which did work, but it was slower acting. This line didn't go down as fast, and it went up again, and so we had to apply a 2nd application. So we can get it to work properly. It's not as effective as Ulticore at this point. The impact of Ulticore on natural enemies we need to look at, but for good control, Ulticore appears to work pretty well, as long as it's timed right. But there's other materials that we need to look at. Some of those are listed here, other BT products, spinosad, and the other ones listed there are all registered for use in grapes and may have potential. And they're all materials that are fairly selective and would work in our sustainable grape IPM system. So future work we're going to look at is we're going to look at some experimental approaches to determining the economic impact on grape production and quality, in small scale replicated block experiments, small block experiments, and going right through to harvest and taking quality assessments at that time with different levels of infestation. That's the only way we're going to get a good answer to that question, I think. Optimal timing of spray application will refine that further, and possible cultural control of overwintering pupae. This is something that's occurred to me fairly recently, because as I mentioned, it is apparent that there is already high overwintering mortality. And I came across a paper recently on another moth species in grapes in the eastern US, who also overwinters as pupae on the vineyard floor. And they found that just by covering them up, by tilling the ground and covering the pupae up, caused like 80% mortality, because the moths would emerge. They're not being damaged, but they couldn't get out of the soil. So we need to look at if that's a possibility for us too, and just some sort of cultural management during winter could actually increase our apparently already high mortality, to make it make the first generation really very low levels. Possible use of the synthetic pheromone for first generation adult monitoring. I mentioned that we want to do that, see if we can use it in combination with bait traps for the other generations. And the expected outcomes will be, importantly, the determination of economic impact on grape production. I think there's a level of infestation we can withstand without there being an impact on grape production. It's just knowing what that is, and we hope to have that information at the end of our project. The thresholds and timing for sprays will be important, so we minimize the spray application. Also the identification of IPM compatible sprays, of course, that's very important. And we'll be prepared for any future expansion of range of this moth. I mean, it may surprise us and suddenly decide to invade all the other appellations too. So we need to be prepared for that. So I'd like to thank the Washington State Grape and Wine Research Program, also the Washington State Commission for Pesticide Registration, for funding support so far. Alison Leonhard for technical support, and all our cooperating growers at Red Mountain, Horn Rapids and Mattawa. And if we have time, I'd be happy to answer questions.
Yes, we do, Dr. James. So the first question is, why has this leaf folder become more of a problem since 2018? And is it due to the increase to 3 generations?
It could be. Obviously, when there's 3 generations rather than 2, there is going to be more production of moths and more problems. Yes, that could be the case. And the first generation, sorry, the first year we saw 2 generations may have been an odd occurrence, because I think we had outcries about the problem before that year as well. So maybe there was 3 generations in those years too, but we don't know that for sure.
Okay. And then another one, do you know what climate this moth prefers?
Not really, no. No, we don't, because we know very little about its biology and ecology. So no, we have no idea. Even basic stuff like its distribution, we know very little about. I mean, it's because it's so similar to the other species, it hasn't been recognized in a lot of instances, most likely.
Yeah. Any other questions? Those are the only 2 that were up on the chat box or the Q&A. So with that, I think I'd like to encourage anybody who sees this pest in their vineyard to get in touch with Dr. James, so that, if you can work it into your research trials, in that it is so limited.
Particularly if you find it in an area that I haven't mentioned today, I'll be most interested in that. It could well be occurring at low numbers in other areas, and people just haven't seen it and recognized it. So if you ever see a folded leaf in a vineyard, please let me know.
Great, great. And so with that, we'll conclude. You will be getting an email, follow-up email with the late recording. I was a little bit late, but and then there's a real short survey to help us improve for future webinars that's included in the email. So I will continue to keep the industry abreast of results that come out of this project. He's right in the middle. Dr. James is in the middle of it. I think you're just starting your second year, so there's still one more year after this coming. So stay tuned for more information as we move this project along. So with that, thank you very much. And thank you to all who participated today.
Thank you.
All righty, we'll shut things down. Get back to work, everyone.